So welcome to Academic Digest class. Definitely you've heard of the word mechanics. This is a branch of physics that is concerned with motion. And mechanics is broadly divided into two: kinematics and dynamics. So when you talk about the study of motion with respect to the force causing it, the cause of the motion, we talk about dynamics. While when you talk about motion without paying attention to the force causing it, you talk about kinematics. So I normally tell my students that kinematics is all about the equations of motion, while dynamics talks about the laws of motion in summary. So today we're going to treat kinematics. So the study of motion without paying attention to the force causing it is known as kinematics. Now, under this kinematics, there are parameters or terms associated with this, or associated with kinematics. The first one is what we call distance. Second one is what we call displacement. These two things are the same. They both talk about change in position, and this position is represented with x. So they both talk about change in position. The only difference is that this one talks about change in position in a given direction. Why this talks about change in position and it has no business with direction, so it's a scalar quantity. So, and you know that when you talk about direction, you're definitely talking about vector quantity. So this one is a vector quantity. So, but anytime you talk about change in position, say x2 minus x1, you're talking about these two things. I know you've seen textbook where they come and tell you this one is the total position. Let's say x2 plus x1. I've seen that too. But you need to know that they are the same thing. Just that they're talking about the difference in the direction. So sometimes you see some textbook come and tell you this one is x2 plus x1, summing up the whole thing. So it's the same thing. Don't use this. So if I know this, we move to the second thing. So the second parameter, second term associated with this kinematics is what we call speed, and another one is what we call velocity. Now, these two are the same. It's just that speed talks about change in distance with respect to time, while this one talks about change in displacement with respect to time. So you see they are the same. So whenever a question asks you how fast or whatever, it's talking about the two things. But the only difference is just that this one talks about displacement over time, this one talks about speed over time. So now that you know this, that means this is the same thing as saying d change in distance over change in time, and this one velocity is change in x, or you say s, all over change in time. It's talking about the same thing. This one is a vector quantity, this one is a scalar quantity. So that means you need to be fond of this formula, which is velocity is equals to delta x over delta t. And this is the same thing as saying x2 minus x1 all over t2 minus t1 is also equals to is the same thing as saying s over t. Whichever way you see it is the same thing it's talking about. So this is the same thing as saying x2 minus x1 all over t when only time is given. So whichever way you see it, so you've seen some cases where they tell you that s is equals to vt. That is from this formula. Displacement is equals to velocity times time. It's still correct. Alright. So before we move to the third aspect, there's something we call average velocity. So this one is like you notes. I'm trying to tell you to note. Remember, this is introduction. We've not started solving questions. I just need you to understand kinematics. Average velocity. So in everyday to day life, there is no time you come and have velocity. We know that velocity is changing displacement over time. There is no time you come and have, let's say, just velocity v1, only one velocity, only one change in displacement. Let's say you are going from Aba to Umuahia, or from Enugu to Owerri, or from Lokoja to Abuja, or from Bauchi to Jos. There is no time you have just one change in displacement. You can have as many as possible. So what he's saying is that no matter the number of displacements you have, by the time you come and check, this is 1 displacement, 2 displacement, 3 displacement, 4 displacement. So all over 4. You understand? So this gives you an average. Let's say, for example, let's use that we have a velocity of 1 and another one that is 2, another velocity of 3, another velocity of 4. By the time you sum this up, see that this is 1 plus 2 is 3. 3 plus 3 is 6 plus 4 is 10. All over is four numbers that is here. A1, A2, A3, A4. That is 4 numbers divided by 4. 10 over 4 gives you 2.5. So this same thing that I've done, instead of coming to sum up all the velocities and dividing by the total number of velocities, stress, just collect the initial one, the initial velocity, which is u, then collect the last one, which is v, sum it up, u plus v, which is 1 plus 4. It will give you 5. Now, because it's 2 velocities you just took, divide it by 2, all over 2, it still gives you the same thing, 2.5. So that is why we now have what we call average velocity, and this average velocity is given by u plus v all over 2. Very important. So if we know this, if we know that, and this u plus v, this is the obtainable thing. Normally we don't have just one velocity in real life. So the right thing to think of when you're talking about velocity is average velocity. So that's why you see some formulas where you have, since v is equals to s over t, and now to make s subject of the formula, now because that s is equals to v t, that is over 1 cross multiply. So we don't have vt just 1 in real life. So in practical purpose, this is going to be s equals to, replace v with average velocity, which is u plus v all over 2, then times t. So this becomes the first equation of motion. This is our first equation of motion. This is the first equation of motion in physics. And this is the equation that you use to get 2 other equations of motion. Remember, I told you that kinematics is all about equations of motion, while the other one is all about the laws of motion. So equation 1. So let's move on. Let's forge ahead. So the next thing is what we call number 3 now, under the terms, what we call acceleration. And we normally see it that acceleration talks about the change in velocity all over with respect to time. So it can be in change in time. So change in velocity with respect to time. So this can be the same thing as saying v minus u all over t2 minus t1. where v is final velocity and u is initial velocity. This can also be the same thing as saying v minus u all over t. You know that by the time you do t2 minus t1, it gives you just t. So that is where we get the second equation of motion, which is a equals to v minus u all over t. Try to make v subject of the formula. You see that a will be this over 1, this will cross equal. So you now have at equals to v minus u. So that this becomes the same thing as v coming over here. You have that is this u coming over here. You have v equals to, moves over, becomes plus u plus at, equation 2a. So this is equation 2, the second equation of motion. But notice that I can also say this. Let me make u subject of the formula here. So by the time I have u here, okay, let's say this u cross over. If you cross over, it becomes plus u. Then as this one is coming over here, it becomes v minus at. So this is equation 2b. So you see it? Yes. So now that we know this, you can quickly notice that it's almost as if we have three strong things. We have speed. Okay, before speed, we have distance, and displacement. Then before we move to speed and velocity, they are the same, but just that velocity has to do with direction, the one that has direction, and this one has to do with the one that doesn't have direction. This one has to do with no direction, this one has direction. Scalar, vector, and acceleration is a vector quantity, so acceleration. So just as I've done it now, notice that anytime you are moving in this direction, they give you the distance of a body is this, is given by the equation, let's say 10 is given by the equation 10t square. Find speed or find velocity. But for the fact that what you are given is distance, and notice that it's going in this direction. So when you are moving in this direction and you are given an equation of motion, whatever it is, what you do is to find it, you differentiate, because you can derive velocity from displacement, you can derive acceleration from velocity. So you can see that that means that if I have distance to velocity, you differentiate once, you d1. Why distance to acceleration, you differentiate twice. So velocity to acceleration, if a question is given to you as an equation, let's say equation of a motion is given by 10t squared plus 10t cubed, this one, and they say that equation, they say the distance of a motion is given by the equation or whatever. For the fact that it's distance of velocity is talking about, they're telling you to get acceleration, or they give you distance to find velocity. All you need to do is you differentiate. So you do d1, you differentiate once. But if it goes the other way around, say you are now given acceleration and you are asked to use the equation or the question given for acceleration to find velocity or to find displacement, all you need to do is to integrate. Notice the arrow, integrate. So acceleration, you integrate. I know you already know how to integrate, so don't worry, we'll still learn all those things with questions. We are not solving them. Acceleration to velocity. Acceleration to velocity, you integrate once. Then acceleration to maybe distance or displacement, you integrate twice. That means that velocity to distance or displacement, you integrate once. Notice how I'm doing it. You integrate once. You know the symbol for You know this is the symbol for integration. Don't mind the fact that I'm writing it like x. You integrate. So normally I write it this way, so you just get it. You integrate. So I'll still teach you this. So when you're going this way, you integrate, going down. So the next topic, the next thing I'm going to teach you, after this, you need to be aware of, note, what we call instantaneous velocity, instantaneous acceleration, or whatever. So whenever you hear this instantaneous, it's more like taking you to a graph, trying to take you to a graph. And what he's saying is that, as for example, notice that if this is v area, this is time, and we know that I will normally tell my students to always see acceleration as this, then constant speed as something like this, then velocity as this way. Reason is from this graph, because see, velocity will always be this way, time will always be this way, and you know that whatever you get here at the end of the day, let's say you plot a graph, whatever you get at this point will be v over t, which is equals to acceleration. So it's trying to tell you that as this thing, as you are opening, as this thing is going to a point where the time is coming to a stop. See, as you progress at a point, it comes to a stop. So you see that the more slope you have, the more your time tends to zero, because your time must come to a stop. So whenever, I want you to think of it this way, that whenever you're talking about instantaneous acceleration or velocity or whatever, all you're thinking of should be on how you are using it on a graph, plotting or finding it from a graph or in a graph aspect, or your slope. And that's where you will see questions, much of questions that relates to equations of motion and the rest. When we start solving question, you understand. So always see that velocity is this way, acceleration goes this way, deceleration goes the opposite way, and then constant speed goes this way, then your time this way. So if you know this, let's move to equations of motion. So remember, we've gotten equation 1, and from our equation 1, we got that s is equals to, displacement is equals to u plus v all over 2. This is average velocity times t. So down, remember that this is equation 1. Then remember that equation 2 gave us that v is equals to u plus 80. That's what equation 2 gave us. So all you just need is take equation 2 and put inside equation 1. Anywhere you see v, replace it with u plus 80. So that s now becomes u plus 80 all over 2 into t. So that this becomes 2u plus 80 all over 2 times t. Now notice that is the t outside. Now notice that this t will times everything here, so that you now have that s is equals to 2ut plus 80 square all over 2. And now s is equals to 2ut over 2 plus 80 square over 2. LCM is 2, so it's the same thing. This cancel this, so that you now have that s is equals to ut plus 80 square over 2. And this thing is equals to, the physicists now say that this is the same as plus half 80 square, and mathematically is correct. If you carry this and times, it gives you the same thing. So that's how we got that s is equals to ut plus half 80 square. This is equation 3. So if you still remember, this is equation 2a. So if you carry equation 2b and still plug anywhere you see you solve, you will get equation 3b. But we are not doing that today. So let's go to the fourth one. The fourth equation of motion.